Hello there! Today we're going to be talking about everybody's favourite thing in the world, word problems. And specifically, we're going to be talking about word problems that involve linear equations. Specifically, we're going to be talking about word problems that ask you to find and maybe even use linear equations. And specifically, we're going to be looking at word problems that have you finding and maybe using linear equations where they don't actually give you the slope in the problem. I hope you like that intro. I practiced. Alright, before we have a look at our examples, let's have a look-see at these here tips. And first things first, we're almost always going to try to put our equations that we find into slope-intercept form, aka y equals mx plus b, where m is the slope and b is the y-intercept. Understand that this isn't always going to be the best course of action because sometimes situations lend themselves a little bit more to standard form as opposed to slope-intercept form. And for now, let's just assume that we're going to cover those in a different Auducation video. In a different Auducation video, we cover the topic of linear word problems where you have to find the equation and they give you the slope in the problem. In this video, we're going to find out what we do when we're not actually afforded that information, at least not directly. Say if you're not given the slope, you're probably going to be given a couple of things that can be turned into points. And you know you'll be able to make points when you have a couple of different values associated with each other, like in our example here. It says in 2019 the annual precipitation in Connecticut was 50 inches. Since 2019 and 50 are clearly associated with one another, we're going to go ahead and create the point 2019, 50. Here's a good note. Anytime one of your values is a time value, let that be the x value, because most things depend on time and not the other way around. Now most often you're going to be given 2 points, and the only sensible thing to do with 2 points is to find the slope between them. Once you have the slope, you can plug into y equals mx plus b, and then if you have to, solve for b and use the equation however it is that they ask you to. And of course, always think about what the question is asking you. Sometimes finding the equation is just a small step in a much larger process. Alright, let's look at some examples. Our first example reads, in economics, the concept of inflation describes the way in which the price of commodities or services increases over time. For example, the cost of a loaf of bread in 1955 was about 20 cents. In 2013, a loaf of bread cost $1.50. Assuming linear growth, write an equation for the price of bread y, x years after, oops, it's supposed to say 1955. So much for proofreading, eh? Regardless of any typos, the first thing I'm always going to look for is paired off numbers. Here, I see that 1955 is associated with 20 cents, and I also see that 2013 is associated with $1.50. I also want to take note of the fact that x is defined as years after 1955. This is important because it's going to change the b value in my final equation, so I don't want to put the point 1955, 0.20. Instead, I'm going to think of 1955 as 0 years after 1955, and then the 20 cents will remain. We're going to do something similar for our second point here. We might want to put 2013, but based on the way that x is defined, we're going to call this 63, because 2013 is 63 years after 1955, and then the price of our bread. Alright, the ultimate goal of these problems is trying to find an equation in y equals mx plus b form. That means we need to find our m and the b for our particular situation. Since we have 2 points, let's find m by using the slope formula. That is y2 minus y1 all over x2 minus x1. These variables with subscripts represent the actual x and y values from your point. Now, it doesn't necessarily totally matter what order you put the things in, but if you use the y value from the second point first in the top, use the y value from the second point first in the bottom. That's why we're going to have 150 minus 20 cents over 63 minus 0. Doing all of our subtraction, we're going to get $1.30 over 63, and this simplifies to approximately 2 cents or 0.02. Okay, so we have our slope. That means in our equation this 0.02 right here is going to stand in for m. Now the question is, what are we going to put down for our b value? Now to figure that out, we're going to have to determine what b represents in our actual scenario here. b, as we know in general, represents the y-intercept, which is another way of saying the original amount. But for us, that translates to the original if you will, cost of the bread. Well, I think we have that information already. That's the 20 cents. And now, armed with this information, we're going to go ahead and write our final answer. We get y equals the growth rate of 2 cents times x plus our original cost of 20 cents, aka y equals 0.02x plus 0.20. Alright, let's move on to another example. Here we have, in a simplified model, the population of a certain species of deer in a particular biome depends exclusively on the amount of forested land in acres. It is known that areas with 100 acres of forest can sustain 2,400 deer. Furthermore, areas with 250 acres of forest can sustain 4,500 deer. If the deer population increases by a constant amount for every acre of forest, write an equation describing the deer population y for an area with x acres of forest. Now, I've already highlighted my ordered pairs here, but it's important to determine what my variables stand for. Here, x is the acres of forest, and y is the deer population. Therefore, when we set up our points, we're going to put our acres first, and then the deer population. That's why our first point is going to be 100, 2,400. And our second point is going to be 250 acres, 4,500 deer. Once again, we're trying to find an equation in y equals mx plus b form, and we'll start by hunting down a value for m. We do this by using our trusty slope formula, m equals y2 minus y1 over x2 minus x1. And now we plug in the values from our points. I'm going to put the 4,500 first because that's going to make my subtraction easier. So I'm going to have 4,500 minus 2,400 on the top. And because the 250 is in the same point as the 4,500, I'm going to put that first in the bottom to get 250 minus 100. Subtracting, we get 2,100 over 150. And this, my friends, simplifies to a very nice number of 14. So we did it. We found the slope. That means that 14 is m. But how, we bemoan, do we find b? Last time we were given a y-intercept, even if we didn't know it. It was the point that had the 0 for x, but we don't have that this time. So what are we to do? Well, one technique we could employ is by plugging in values that we actually do know into the equation and then solving for b. So for now we know m, and that's going to give us y equals 14x plus b. But that by itself isn't getting us any closer, is it? We still have too many unknowns, specifically the y and the x. So what are we to do? Why don't we go ahead and plug in values from our points? And FYI, using the smaller point is usually going to be the easier thing to do. So replace y with 2,400. We have m is 14 and x is going to be equal to 100. And b, well, we're trying to find that, aren't we? We're going to evaluate here by multiplying the 14 times 100 to get 1400, and then we have to solve by moving that 1400 to the opposite side of the equation. And all said and done, we're going to get a very nice value for b. We're going to get 1000 equals b. And technically we could write our answer now, but I'd like to figure out what exactly b means in this context too, because that's always handy information. Remember, b is the y-intercept for about the 400th time. But it's also the original amount. Right, we said that before. What's the original amount here? Well, it's going to represent the population of the deer when the area has, ready for this, 0 acres. And that would be of forest. I'd say it's about time we wrap this up. Our final answer is going to be y equals 14x plus the original amount of deer, 1000. Y equals 14x plus 1000. Alright, quick review. Find the associated values in the problem, set up points, find the slope, plug into y equals mx plus b, solve for b if you have to, remember what the question is asking. I think I've covered it. See you later!